So this presentation is going to be real different than what we've seen. This is going to be more of a history of dredging as it progresses through the decades. And a lot of that does pertain to the products that are here at this presentation. So we're going to start back actually before 1890 and actually move to where we are today and where we see us going in the future. This presentation is going to primarily be with hydraulic dredging. That's pumping with a pump, not so much the mechanical, just because of the time constraints that we have. So we're going to kind of follow the line, the path line, and this whole presentation is really, like I said, just history. This is pre-1890, so this is going to be actually 1850s to 1890s, and these are the events that kind of led up to the beginning of dredging, primarily in the United States, but also in Europe. We had the U.S. Homestead Act. The U.S. Homestead Act, basically, people who wanted to move west in the early development of the United States, if they wanted to move west and they staked a claim, the U.S. would grant them that land. So basically land for free. So this caused a huge movement of people west. We had the Transcontinental Railroad being put in at the same time. And then shortly after the Transcontinental Railroad got in, we had the California Gold Rush. Gold was discovered in California. So we had a mad dash of people now moving to the western part of the United States. At the same period of time, we were coming out of the end of the Second Industrial Revolution, which really brought portable steam equipment into different pieces of equipment. The Statue of Liberty was being built. The electric lamp was just developed by Edison. And believe it or not, that's an early Coca-Cola bottle. Coca-Cola was developed right in the 1880s. And at the same period of time, there were already patents issued for a two-spud dredge. There were patents issued for cutter suction dredges. The control room you see there is actually off of an early mechanical dredge, but when they called it a lever room, they really meant it. A guy had to get on that and actually pull to make the machine swing and move. And the patent down to the right is an early swinging ladder dredge, and you'll see later, this is a patent that was done back in the 1880s, and it's very similar to the wide format swinging ladder patent that DSC was just issued in 2019. So way ahead of its time. So we'll move now into the 1890s. We have the gold rush taking place up in the north, up in Canada. We have the Spanish-American War. Westinghouse beat out Edison, and actually AC power was chosen over DC at Niagara Falls. Marconi invented the radio. The first three-phase industrial motors were built by Tesla, and Mr. Diesel invented the diesel engine. Now this is only a little over 100 years ago. At the same period of time, the modern cutter head was already being patented. This is 1890. It hasn't changed much in 100 years. We had a moving or a tilting spud that was already developed. That's used on most swinging ladder dredges today. That technology was developed already back in the 1890s. Now it's been perfected as we go. There's not a lot of photographs from that period of time, but the dredge ram, which is the upper section, and it's actually a graphic, that was the first modern cutter suction dredge in the United States, probably in the world. It was a paddle wheeler, and it actually kept the Mississippi open in the Missouri area. So it was one of the dredges that tamed the Mississippi. And at that period of time, the European market was more mechanical dredges, and the U.S. market was more hydraulic dredges. I don't know why that is, but that's just kind of the way the history worked out. There was a patent issued for an electric-powered dredge back in 1890. In the mining industry today, almost everything you see is electric-powered, not only because it's more efficient, but because of the environmental requirements with diesel fuel. And then the picture at the bottom is an early suction dredge. The early suction dredges were basically boats that they cut the front out of. They had a boom that went up and down, and most of them side cast. So they'd pick the material up from the bottom, they'd have a pipe hanging out the side, and they'd dump right on the side. So they would cut a slot so that you could have navigation. So it didn't move the material far, but it moved it out the way so you could have boat and barge traffic. The 1900s came along, We had the Nobel Peace Prize. We had the Wright brothers flight at Kitty Hawk. Oil was discovered in Texas. We had the Galveston hurricane of 1905. It killed 8,000 people. This caused a lot of dredging and coastal restoration work all the way back then. People forget about this hurricane, but it was really, really bad. There was also no predicting back then. So this spurred on the Weather Service to actually get to where they could start predicting these storms. In this decade, Ford came out with the Model T and the assembly line. The Zeppelin was developed. Holt built the first tractor. Holt ended up becoming the Caterpillar Corporation. And there was early sonar devices developed basically to detect icebergs moving. In that same period of time, the ball joint was developed. The ball joint is part of a pipeline system that allows two steel pipes to flex in the middle, and that was really critical for a dredge, not just to side cast, but actually to be able to pump a pipeline behind it so it could swing. The suction dredges got larger. This one actually has twin boilers in it. And then you had some cutter suction dredge being developed now. And these are actually fairly large machines physically. Pipe-wise, usually not. But all steam-powered, and all of these dredges were crewed. They had to have like 20, 30 people on this just to keep the equipment running. The trend today is completely different from that. We don't put people on the dredge. We put people on quarter barges, and we try to keep them away from hazards. But you can imagine you got steam boilers in here and a whole bunch of people sleeping right on top of them. It didn't make for a great situation. We also had the trailing hopper dredge patented back in the 1900s. So this technology is now coming to its, I guess, the peak of its development. But it was actually patented over 100 years ago. The drag arm and the whole bit, just like they're using today. In the 1910s, World War I happened. We also did the Panama Canal. That was started by the French and basically finished by the Americans. It was a combination of mechanical dredge and hydraulic dredge. This put my biggest competitor in the U.S., Ellicott, on the board because they were the ones that actually built the hydraulic dredges that went into the Panama Canal. Commercial air flight, believe it or not, that is a commercial air flight. So the guy in the back seat paid. That's rough. The same period of time we had the Titanic sink. A lot of the things that happened wrong in the Titanic changed the way we manufacture not only ships but dredges. The slip ring electric motor was developed. That allowed us to vary the speed on AC electric motors, which was very important in things like hoists that swung a dredge or dredge pumps. The first talking motion pictures were created, and arc welding was invented. Arc welding was big because the Titanic was primarily all riveted, and a lot of the failures they had was rivet-type failures. In the 1910s on the dredge side, all of those great big levers moved to air controls, pneumatic controls. So now you could have smaller guys running this equipment. It was much more comfortable. You started having much larger cutter suction dredges and much more powerful. This particular dredge was the dredge General Gillespie, and it was built in 1915. My father purchased that dredge back in 1990. It had already been repowered diesel, and his plan was actually to put it back in service. That was an all-riveted, what they called cold steel hull, almost no rust in it. It ended up being not economical to do, and we scrapped it, but that machine operated for almost 100 years, which is typical for the U.S. dredge market. It's fairly old. It's only becoming new now. And then the bucket wheel excavator was patented as well, which is used in mining applications throughout the world. In the 1920s, we had the Roaring Twenties. We also had the U.S. Highway Act of 1921. This was the first big act where the federal government got involved in creating roads for the new automobiles. This spurred on an aggregate industry in the United States that we'll see later how it really flourished. But this actually started aggregate dredging in the U.S. We had the Florida land boom. What you see there is construction that happened. Miami was a swamp. So back in the 1920s, there was mechanical and hydraulic dredges that were basically filling in the property of Miami to create the land that you see today. Industrial stick welding, the arc welding was invented. Now actually it's out in force. There's stick welding going on everywhere. The Model A Ford was developed. The first television, you can imagine how much fun that would be to watch. Color movies were invented. And the first commercial fathometer. That's back in 1920. On the dredging side, the spud carriage was patented in 1920. When you go to any dredge seminar now, it's spud carriage, spud carriage, spud carriage. That's a 100-year-old technology. There was further development on some of the cutter suction dredges, and actually you started to see some mid-sized cutter suction dredges like the one down on the left, where they didn't have to crew it so much. That became more and more popular. You can see environmentally how nice some of the steam engines were. Most of these things were burning coal. It was no environmental protection. We get to the 1930s and we had the Great Depression. We had World War II. The Tennessee Valley Authority, that was a U.S. government program basically to open up the waterways and control flooding all throughout the central part of the United States. It was done really to alleviate a lot of the Great Depression, but it spurred on tremendous technology for the dredging industry. Hoover Dam was built. Industrial diesel engines, that being a GM 171, which not many people have seen that, came into service. The Volkswagen Beetle was invented. Radar was first used to detect planes coming in, primarily from war. The ballpoint pen was developed. The first helicopter was flown. And the gas turbine engine was invented. This is 1930. So a lot of the things that we think of commonplace today, almost 100 years ago, were already being done. This was how we did hydrographic surveys back in the 1930s. It was either a lead line or a sonar, but it was all done with transit and stakes. I mean, it was very crude and very primitive. The dustpan dredge was developed in the 1930s. DSC just replaced this dustpan dredge in 2010. So this machine operated for 75 years. It was still working today, up until that point. 26-inch pipeline. The swinging dredge was patented. On this particular dredge, the back half of the dredge remains stationary and the front half of the dredge swings from side to side. That's also used in mining today. And then diesel power finally came to the dredges. And you can see the two dredges up in the right corner are actually diesel powered. The lower one was a steam engine, a steam dredge that had been repowered, but the upper dredge was actually built new as a diesel machine. And then the anchor boom was patented. Anchor booms are used in locations where the water is very shallow and it's very difficult to move anchors from location to location. So they'll outfit the dredge with these booms and the dredge can actually move its own anchor. It's not as efficient, but if you can't get to the anchor in the first place, it sometimes becomes the only way to do it. The 1940s, we had World War II. We broke the speed of sound. We had the Marshall Plan to rebuild Europe after the war. The Willys Jeep was used, and that's what most of our troops moved around in. And gas metal arc welding came on. Gas metal arc welding is a much faster welding process and reliable process than just the stick welding. And that was used in building a lot of the ships during the war. In the 40s, because of the war, the U.S. invested heavily in its own hopper fleet. So they actually, in 1947, right after the war, the U.S. bought 8 hopper dredges. They also bought a whole series of cutter suction dredges for all of the invasions that they were having to do. The Hoffer valve was patented. That's a suction relief valve that's commonly used on dredges today. When the dredge is trying to pull in more sand or dirt than it can do and the pump starts to shake and cavitate, that basically opens up and allows clear water to go in and dilute the mixture. So that technology now, we have our patent called Maximizer. There's Convac. There's a whole, every dredge manufacturer has their own thing, but all of that started back in 1940. And then the cutter suction dredges got larger, and then actually the dredge on the bottom right is a swinging ladder dredge or a canal dredge. That dredge, actually, the patent came out in 1910, but this was the first commercially available, and that was manufactured by Ellicott as well. The boom swings from side to side as opposed to the whole dredge, and it can cut a very narrow, very precise canal. The 50s came along. We had the Great Flood in 53 in the Netherlands. This really put the Dutch, after this event, ahead until now. They developed all kinds of dredging techniques and water-moving techniques after that flood to protect themselves. The St. Lawrence Seaway was opened up, which created a lot of dredging projects. We also had the Korean War. Agribusiness, the huge farming businesses, started to develop in the 1950s. That's still prevalent today. The U.S. Highway Act of '56 basically gave us the interstate system in the United States. So if you travel down the interstate today and you see all the little ponds left and right, those aren't natural ponds. Those are all borrow pits. They had a dredge in every one of those ponds. They would locally mine the material to build that highway. So if you imagine all of those ponds as you drive down interstate, you have that many today hidden in the woods that's producing material for sand and gravel. So the number of aggregate dredges just in the U.S. is tenfold what the number of navigation dredges is. And then we started to have commercial jet airline flights. We also had civilian Loran, the 55 Chevy, Bel Air. Hydraulic machinery came into play, which that greatly reduced the size of components, not only on dredges, but on tractors, cars. Hydraulic planetary winches, where the speed control was very, very accurate. First credit card was in the 1950s. The hydrogen bomb, and the transatlantic phone system. The same time, patents were issued for the first lay-down spud system. This allowed spuds to be laid down where they could go under bridges without the dredge having to be reassembled. This at the time was the largest portable cutter suction dredge. It had 12 diesel engines on it. Back then, the diesel engines, typically you could get them up to about 1,500 horsepower. In order to get the power that they needed on this machine, they actually broke it up as 12 individual engines. So you can imagine what it took to keep this running. It actually operated one dam project and was abandoned on site. This would be more what you would see in a dredge control room in the 1950s. And you'll notice there's no navigation equipment at all in there. Sometimes you'd get a compass. That would be the extent of it. And actually, patents were filed for a modern swinging ladder dredge in the 1950s. The 1960s, we had the Vietnam War, the Cold War, landed on the moon, global oil exploration. The first industrial, inexpensive gyro compasses started hitting. I'm not talking about the ones just on ships, but stuff that you could put on smaller equipment. Finally became affordable. The picture on the upper right is Marina del Rey in California. California's inland was completely modified by hydraulic dredging. The Aston Martin was out. That was the famous one in Goldfinger and James Bond, and the 8-track tape. At the same period of time, the horizontal auger dredge was developed. That was up in Minnesota. That's the picture up top. There are more of those type of dredges in the world than any other type of dredge. That machine basically moves linear, and it cuts a swath, and every chemical plant almost in the world, in the settling ponds, will have a machine like that. There was a global development of hopper dredges by almost every developed country at the time to open up their waterways for trade. The Western Dredging Association and the first dredging conventions took place at this time. That's when everybody finally started to get together and talk about what's working in one country or working in another country or working on specific projects. The chain ladder was developed by Eagle Iron Works in Iowa. That looks like a chainsaw, basically, and it cuts a slice down through the bottom, and it moves the large rock back behind the dredge on the chain so that the dredge can mine sand and gravel. So it's very, very prevalent in the central part of the United States, and it allowed hydraulic dredges to work in deposits that they could never work in before because of the size of the rock. Amphibious dredge technology was patented. Submerged cutter drive technology, so this is some of the turbo machinery, but not only the cutter head, but the whole cutter power unit now is mounted on the ladder and goes underneath the water. And then the boltless or the modern ball joint, which on all of the big dredges you see now, they can slap these ball joints together and turn a lock and basically add pipeline like you wouldn't believe. The 70s, we had the Vietnam War, the Clean Air Act. China reemerged as a world power. We created the EPA. We had the Nuclear Non-Proliferation Act, and we had the oil embargo of the 70s. At the same time, developments took place on the industrial flow meter, both magnetic and Doppler, industrial densitometers. Both of those were products of the war, the Cold War. Commercial supersonic flight, the Trans Am from Smokey and the Bandit, color TV, the first personal computer, and the internet was created. Now this is the internet, this is the broad internet, not the World Wide Web. In the dredging world, the first submerged dredge pumps were created. Submerged dredge pumps allow the dredges basically to beat the vacuum bottleneck that they've always had. Actually, they perform better the deeper they go. They had large self-propelled cutter suction dredges, which would be the one on the right, and it also has a freestanding spud system. Controls now are proportional in the dredge, where the operator could actually get feedback and very accurately control the speed of the machine. The first dredge production computers came into place, basically showing velocity and density and giving a cubic yard per hour production rate. Polyethylene plastic pipe was first used in the 70s in dredging applications. That revolutionized the small dredge market. Now the pipeline became very, very easy to move and very inexpensive to maintain. And back in the 30s, we had seen the development of the gas turbine engine. This is the only gas turbine powered dredge that I know of in existence. It was powered from 4 GE locomotive engines at 8,400 horsepower each. So this dredge was about 43,000 horsepower. At the time, the most powerful dredge in the world burned 33 gallons of bunker C fuel a minute. So you can imagine how efficient that was. We get to the 1980s, we have the Space Defense Initiative, the Challenger disaster, the savings and loan crisis, civilian GPSs, handheld GPSs, commercial cell phones show up, the World Wide Web is created, early multi-beam sonars, and that's just to process the data coming in. So you can, when you look at what the T-20 is now compared to what, just on the processing side, it's incredible. The DMC DeLorean, the Macintosh computer and the IBM PC were developed. The CD-ROM was developed, and EPA started creating Superfund sites for environmental cleanup. At the same time, very small dredges came on the market, and a lot of this was because of the highway program, and a lot of this was because of environmental cleanup. So the dredge on the left was the first dredge that I ever designed. I was 17 at the time, and that was back in 1981. And then that's an Ellicott 370, almost identical looking machines, almost identical performance. The first catamaran mining dredge, the catamaran dredges were important because you could actually extend the length much less expensively than you could with more conventional dredges. So there's no center section in this machine. The equipment just floats across between the two tanks. And then hollow shafting or torque tubes were first used on dredges. And that allowed ladders to get much longer, so dredging to get deeper. We get to the 1990s, and we had the Hong Kong reclamation, where they built airports out into the sea, more Superfund sites, the fall of the Berlin Wall, the Persian Gulf War, and the U.S. Clean Air Act, which has changed all of the diesel engine technology. All of the Tier 4 requirements we have today all started back in the 1990s. RTK came into place. Notebook computers came into place. The USB was created. Toyota actually jumped into the U.S. truck market. Bluetooth was created, and text messages became popular. At the same time in the dredging, the cutter suction dredges got massive. This is the Leonardo da Vinci. At the time, it was the largest dredge in the world. Deep digging mining systems and spud systems came into place where we could mine because of permitting issues. The mines would go deeper and deeper because they couldn't get new land permitted. And then submerged pump swinging ladder dredges were developed basically for Superfund cleanup site technology. In the 2000s, we saw the development of the offshore islands, the Palm, the World, the Universe, the Dolphin. That was all done with cutter suction dredges, hoppers, and mechanical dredges. We had the 9/11 attack, Hurricane Katrina, which unfortunately I'm very familiar with, industrial AC drives. That was spurred on by the locomotive industry. DVRs, the iPhone, PT Cruiser, and flat panel displays. And on the dredging side, we had more control development and actually PLCs and PCs now being used in the dredging process. VicVac is an environmental cutter. The viscous excavator was one of our patents. And then the cutter at the bottom is an articulated cutter, all developed for environmental cleanups. The large hopper dredges started to come onto the market. And they almost had, to this day, they have a race to see who can get the biggest. Every year, somebody's cutting their hopper dredge in the middle and adding a couple more cubic meters into the length. The shock-absorbing spud system was patented by IHC, and deep digging, very deep digging CSDs were created. This one actually mining 200 feet below the surface in Florida. 2010, the decade we're in now, we see the Panama Canal expansion. That's changing shipping all over the world. Also changing the ports now. All of the ports all over the world now have to go to 55 feet to handle the new vessels that can move through the Panama Canal. Climate change fears became very prevalent. We had global national disasters, tsunamis, hurricanes, earthquakes. Singapore did a huge reclamation on their harbor. Rotterdam World Gateway was opened, huge for shipping. The iPad was created. Tesla came out with the Model S. Artificial intelligence became commonplace. And we have global cellular connectivity. On the dredge side, we now have, because of the cellular networks, we have SCADA systems where you can monitor every dredge we build now, from the smallest to the largest. I on my iPhone, can control it anywhere in the world. That's not just DSC, that's every one of the dredge manufacturers. The SCADA systems are pretty incredible. The controls on the mining dredges went from very complex to very simple, and that's primarily because the operators that are running this equipment usually don't have a high school degree. So we're asking these guys to produce more and more tons, and we're actually giving them less and less education to work with. So the controls have basically gotten now to where the dredge is pretty much running itself. On the flip side, when we get to the great big cutter suction dredges, the massive ones, self-propelled, they've gone the other way, and they've gotten very, very complicated on control systems. Very, very, the operator is involved in everything and just about has to be trained or be an engineer in order to run that equipment. In this decade, the wide format swinging ladder dredge was patented. This basically is a combination of a conventional dredge and swinging ladder, but it allows the swinging ladder functions to take place over the same width of cut as a conventional dredge. So it's actually very efficient, actually a little bit more efficient than a modern cutter suction dredge, even with a spud carriage. We had large U.S. environmental cutter suction dredges developed, and a lot of that is in the tar sands area of Canada. The spud glider, which is a mini spud carriage system, was patented. Deep mining cutter suction dredges that are actually mining more than 150 foot deep and actually cutting rock. The modern dustpan dredge, this is the dustpan dredge that we actually replaced the one that you saw earlier with. And as of this year, the dredge Spartacus will be launched by IHC, and it's a 45,000 kW machine with 60,000 horsepower, and it's LNG powered. So it's going to be the first LNG powered dredge. And what we see forward the next decade is bringing all of these technologies together on the dredge, where it's all part of the dredge control system. So we've already got artificial intelligence where the machine is more or less running itself. We're going to bring in the navigation component, the sonar component, the connectivity component. And I know we had a question early on about autonomous. You're going to see that in the 20s. So thank you very much. Any questions?
Teledyne Marine. Everywhere you look.